Hello everyone, welcome to my YouTube channel once again. I hope you have subscribed it already. So in this simple video tutorial I will show you the mating of cylinder piston assembly. So in this mechanism we basically need 5 components: this crankshaft, this connecting rod, this piston cylinder, and these two ball bearings or roller bearings we have used here them as support. So what we will do, we will begin with the part of crankshaft. So first we will make crankshaft, then we will make connecting rod, and at the end we will do assembly, and I will show you different mating commands as well. So let's begin. I close this one, save all, rebuild and save the document I have already made. No, I will made once again. Go to the new parts, go to the front plane, sketch. So I will use the dimensions which are predefined, or I am using arbitrary dimensions because millimeter, gram, second. So I will use arbitrary dimensions because I gonna just do demo of this piston cylinder assembly. I am not making for a construction purpose or anything else. So the radius of this, go to smart dimension, give it a radius of almost 100 millimeters. Done. Exit, go to features, extruded boss base command, and extrude it up to 50 millimeters. Here it is. No, sorry, 50 millimeter is very small. 200 millimeters. Here it is. Control 1, choose this face, make it sorry, I think yes, choose this face, choose sketch, zoom in, zoom out. So what I will do, I will choose center line, here. So I simply choose line command. I will choose line command here. From here I will go upward and horizontal line. So I will give dimensions up to 200 millimeters, and dimension I will again use dimension command, dimensioning from here to here up to just 60 millimeters. It will come close, and I will again use dimension command for dimensioning this point to this point vertically up to 10 millimeters. Here it is. Now it is almost defined. I will use mirror command. I will mirror this line, and I will mirror about this center line. Here it is. Now we are almost near. So now I will use arc command. Arc command, center point arc command. From this to this point we will choose an arc. Sorry, yes, up to this. No, sorry, we will not use arc from here. So I will use arc command from center point, arc command from this point to this point, and up to this line or this point. So now zoom out. Again use the arc command from this point to this point, sorry, opposite direction, up to this point. No, here it is. I think we are almost very near. The figure is not completely exit. Control 7. Try to, I think so we have done something wrong. We haven't used the exact command. So simply exit, sketch 2, make it normal, and edit sketch. So what we have done wrong, I will try to find what we have done wrong. We will delete this arc. So we will simply drop to this point, and from this point to this point. No, it is almost defined. Control 7. Okay, go to, no, it is defined. Just 10 millimeters, not more than 10. Okay, 20 millimeters, just 20 millimeter. Make it normal, sketch. So what was the diameter of this circle? This circle diameter was 100 millimeters, and what we will do, make it normal. We will draw another circle up here with a diameter, sorry, a little bit near, diameter of 100 millimeter and radius of 50 millimeter. So click OK. Smart dimension from this point to this point of 60. So it becomes very near. Move little bit further, 70. And what we do, we will simply give dimensions to this circle as not 100, little bit less, up to 80 millimeters. No, it is almost done. So Control 7, exit, extruded boss base. Instead of 20 we use 50 millimeter, sorry, 100. No, 100 is fine. So what we will do, we will go to this face, make it normal, sketch, go to boss, extrude boss 2, choose this sketch, convert entities, sketch 4, normal, and Control 7. Here then go to extrude boss base. So just extrude up to 20 millimeters. That's fine. Now you can see that we have used convert entity command, and with the help of convert entity, instead of drawing a sketch, we simply, what we do, we simply made another feature. So select this face as normal, go to sketch. Now we have to do the same with this sketch 1, convert it to control 7, extrude up to 200 millimeters, or we can extrude more than 200, but 200 millimeter is fine. So here it is, we have almost made our crankshaft. So what we will do, we will choose this face, normal, sketch. So what we do, we simply use this command, R command, and with the help of this R command, here it is, click OK, control 7, extrude cut command, yes, through all, both sides, click OK. Now what we have obtained, we have obtained our this arc of the crankshaft. So what we will do, we will simply save, we will give color to this assembly. Go to this library, appearance, metal, select this color, polished copper. Now here it is, control S, save your first part on the desktop with part 1 SLDPRT. Always remember, we have chosen this circle of diameter 100 millimeter, so we have to make bearings about 100 millimeter. Save this part, close this part, again open the new part, OK, part, front plane, sketch, choose circle command, another circle command, and draw another circle. Now smart dimensions, give inner circle of inner circle of diameter 100 millimeter, outer circle of diameter 120 millimeters. Click OK, control 7, exit, extruded boss base up to 20 millimeters. Here it is. Now give it appearance or color of cast lead, it is fine. Control S, save this component as part 2, close this part. Now we will make connecting dot. Go to front plane, sketch. So remember that the inner part or inner circle of the crankshaft was of 80 millimeter diameter, so we will make 80 millimeter here. Instead of circle command, first OK this center part, radius 40, more than 40, I think 60 is fine. Here 60, sorry, again we will use circle command, select this point as center, 60 millimeter, zoom out. So this select line command up to this point, make a line and then draw a center line, because we have to use the mirror command. So if we have to use the mirror command, and this is necessary, we have to mirror this line about this line, it is fine. Now we will give smart dimensions. Instead of 130 we will choose 120, 60 is fine, and instead of this we will use this distance as 400 millimeters. Let's see, that's fine, 400 millimeters. Okay, click tick, control 1, zoom out. What we will do, we will draw a circle here from this point to this point. Draw a circle up to this point. Okay, click OK. Now use trim entities command. Trim this part, again this part. We have seen that this figure is not enclosed. Let's see what we will do. We will zoom in. We will zoom here. Make this point and this point. Make them merge points. Let's see what happened. Here the points are not merged. So what we will do, control 1. Oh, this circle becomes larger. So what we will do, we will adjust by this. Simply select the circle and drag it. Okay, again exit, control 7, extruded boss base. Yes, we have to extrude up to just 20 millimeters because it is fine, not more needed more than 20 millimeters. Here it is. Select this face, make it normal and sketch. Okay, remember that the inner diameter or the overall diameter of the circle or upper circle in crankshaft was 80 millimeters, so radius 40 millimeter. Select here, write 40, click OK, and we have to use another circle here as well. Select this circle, you will get the center point. Take this circle and draw a radius up to 20 millimeter, not more than 20. Here 20 millimeter. Tick OK, control 7, and extruded boss base, extruded cut command, blind through all. No, we got our connecting dot. Look, so we will give color to this part. What I want to choose, painted red. This is fine. No, red is also the color of crankshaft. Go to plastics, use blue. Here it is fine. Control S, name it as part 3. So close it. Now what we have to make, we have to make the piston part, front plane, sketch, left circle of just 100, radius 100 millimeter is fine. I have already said that I am not using the exact or any company given dimensions. I am just using the demo dimensions. Feature, extruded boss base up to 20 millimeter. Fine. So select this face, make it sketch, select this sketch, normal. So zoom, and now here we will draw a center line, first center line from this point to this point. Remember that we have to draw a hook to make it coincident with the upper connecting dot circle, which is of 40 millimeter diameter. So what we will draw a center rectangle here, center point rectangle. Here it is. You can choose your dimensions in this rectangle. Okay, I will use 15 by 50 that's fine. 15 by 50, that's fine. Okay, click OK. Make this point and this point horizontal. Now we have given relation. Use mirror entities. Mirror this line, this line, this line, and this line about the center line. Here we are almost done. So sorry, control 7, features, extruded boss base, extrude up to 50 millimeters. That's fine. Now here we see, now select the plane, front plane. I think right plane is fine. Make it normal. Sketch. So select a circle here in this center of radius 20. So here it is. Give dimensions from this point to this point of almost 45, and this circle of 40. Here it is. Exit, control 7, and extruded boss base. So what we will do, we will extrude sketch plane, mid plane, and we will extrude up to, since we know that we can not exactly know the distance, so mid plane and 50 millimeter is fine. So click OK. Now you can see that we have got our piston. Control 7. We will give color to this piston, a very beautiful piston. Shiny cream wax from plastic is fine. Here it is. Control S. And sorry, I cannot remember the exact dimension of cylinder. So what we will do, we will go to extrude boss base, because we have to make piston cylinder. So smart dimensions, what was that was 200 millimeter. That's fine. Click OK. We are almost done. Save all. Save it on the desktop with part 4. Now our last part is only left, which is the cylinder. We have made piston, we have made crankshaft, connecting rod, and we have made the bearings, 4 bearings. So now we will make piston. Piston is very easy. Just select front plane, sketch it, select circle command up to 200 millimeter, another circle up to, control Z, select circle command, another circle. OK. Smart dimensions 200 millimeter, because piston was minimum of 200. 220 is fine. So control 7, features, extruded boss base, extrude up to 100 millimeter. That's good. Go to appearance, and we will use glass, because in glass we can see our piston. Here it is. Select control S, save it with part 5. Now we have made our all of the parts. We will now begin assembly. Let new assembly. So what we will do, we will select part 1, part 2, part 3, part 4, part 5. Open. The first one is crankshaft here. Now support ring, then connecting rod, then the piston. We will adjust the piston. Here it is. Adjust the piston. at the end cylinder, adjust the cylinder also. Now we are almost near to our mission. So what we will do, the first part, crankshaft is fixed, we will make it float. So I zoom, I will make this edge, go to assembly, mate it with this edge, coincident mate. No, it is done. Now you can see control 1 or control 7. I will show you that for part 1 the front plane is, we will mate the, I want to say that we will mate top plane of the crankshaft with the top plane of the assembly. Now you see that, here it is. Cancel, control 7, make this part part 2, fix. Now you can see that this, it is fully defined. Really sorry, we have to break mate. What we do, make it float, go to mates, select second mate and break it. Here it is. So what we will do, we will mate front plane of the assembly with the front plane of the crankshaft. Go to part 1, select front plane, hit it. So here it is. So cancel it. I want to achieve the rotary motion of the crankshaft, that's why I am doing this. Make second part fix. No, see that the crankshaft is rotating, and that's what I want to achieve. So here we are near to our objective. Now go to the insert component command, insert part 2 again. Now you can see that here we are. Go to this side of the assembly, select this edge and mate it coincidentally with this edge. Now you can see we have given supports on almost every side. So click OK, and part 2 second time, make it fix. Now you can see that crankshaft can rotate, and that's what I want to achieve. So what I will do, I will now mate this circle, I will mate it concentric mate with this circle. Here it is. But what I have to see, it can move here. So what I will do, I know that we can make it another mate. See, that's the distance mate. Select this face and distance mate, distance of up to 20 millimeters, and this face. No, it becomes very clear. Instead of 20 we will make it 40. So it is very very much far away. I will make it 50. 50 is fine. No, click tick. Now you can see when it moves it will not go anywhere, so it is almost confined to only rotary motion. Control 7. Now what we will do, we will mate this circle concentrically with zoom this circle. No, we are almost very much near to our objective. Now see, but what is the problem? Here is again the problem that this can move here and here. So what I will do, control 1, it can move here and here, I have to just make it move up and down. So what I will do, I will, here it is part 4, I will make top plane of part 4, mate it with top plane of part 1. Here is the tight plane, mate it, I want to make it perpendicular, mate top plane. Now you can see that if it moves, oh, I have made a mistake, sorry, cancel, go to the mates and select this perpendicular mate and delete it. Yes, delete it. So what I will do, I will go to part 4, and in part 4 I will make top plane. So I will make, this is front plane, I will mate it with the not coincident parallel mates. Here the front plane, here the top plane, here it is, we have done almost our work. Now you can see when I do, oh, that's again the problem, I have to delete this. No, delete, don't delete this mate. So simply choose, go to part 4, select this top plane, right plane, okay, right plane, and mate it with the not coincident mate, parallel mate with the part front plane. Now see, here it is, almost we have achieved our objective. Now you can see that it is moving away from its place. So what we will do, wait, let's see, it is moving. So what we will do, we will here again set a distance mate, zoom it, select this surface, add a distance mate of just 30 millimeter up to this surface. Here it is, we are almost near to our objective. So click OK, Control 7. No, it is not moving up and down, it is moving with the, so close this part 4. I will tell you what we do. Go to mates, make this mate, here it is the mate parallel. So we want this mate as well, we want this mate as well. So what I will do, I will delete this mate in which we have made the parallel both the piston and the crankshaft planes parallel. Yes, delete it. So again delete these both mates. I am trying to find the solution and I hope I will find this solution. So instead of doing this, Control 1. So see, go to part 1, here is front plane of part 1, but here is the top plane, but we are not concerning with the, we have no concern with part 1. Go to part 4 because we want just up and down motion of part 4. So open front plane, top plane, okay, select top plane, mate it perpendicularly, perpendicular mate, no, not perpendicular mate, mate it perpendicularly with the front plane, top plane of the assembly. Now you will see here. Wait, yes, it is almost straight upward. So what we want to achieve, we have to achieve now the up and down motion of this piston. So what I will do, I will mate this is the top plane, this is the top plane. I will mate it, no, sorry, clear selections. This is the right plane, and I will mate it with the part 4. Here is front plane. I will not coincident mate. What I will do, I will mate top plane with the top plane parallel. Tick. Control 1. Let's see what we have achieved. We have achieved almost our objective, but we cannot achieve here. See, wait, go to part 4, select top plane and go to part 1, select coincident mates with part 1's here right plane. Here it is. Let's see what we have. No, it is almost fixed. So delete this mate, simply delete it. Yes, delete it. So let's see what we can do further. Control 1. Now you can see it is almost above. So what we will do, we will simply, with the cleverness, we will simply go to cylinder, select this surface and mate it concentric mate with this surface. Here it is. We are almost with our clear selections. I have chosen the edge. Select this surface and concentric mate with zoom in, select the surface here. Now you are almost done. Let control 1 and now you can see that when control 7, no, with the cleverness what we will do, we will simply fix part 5 here. Fix it. No, let's see. See, we have achieved our objective, but what we will do, we will have to adjust part 5. We have fixed it. We have made the part 5 fix. Simply float. So what we will do, control 1, take this here, adjust here, and take this only above this center point. Control 7, make it move upward, but we can't move. See, this is concentric mate, so delete this mate again, delete this mate, we'll mate it again. Let's see, move, no, select this cylinder, go upward, control 1. Here you can see it is almost above. Yes, adjust here, it is almost above the crankshaft. So what we will do, we will simply now mate it concentrically with concentric mate with this, zoom in with this surface. Here it is, control 1. Now what we will do, we will make this part 5 fix. So see, see, the piston is only moving upward and downward. Okay, what we will do now, we will save here assembly, control S, rebuild and save the assembly on the desktop with assembly 1. Save, minimize it. We can also, instead of opening component, we will go to this, cancel, make it open. So what we will do, we will simply go to part 4, part 5. So what we will do, we will edit this extruded boss base, we will edit it. So instead of extruding it upward, what we will do, we will choose mid plane. Here it is, control S, tick, go to the assembly. So what we will do, control 1. See, I have made that cylinder very small, so you can make the cylinder little big, so the piston must not come out of this cylinder. We can make it again, control 7, go to boss extrude 1 of part 5, edit features. Instead of 100 sketch mid plane, we can use 120. See, 120 or 150, I think this is fine. Go to assembly, control 1. See, no, it is again coming out of the cylinder, so we will again adjust it, control 7, boss extrude 1. Again, instead of 150, we will use 170. I think that is very much fine. Click OK, come back to the assembly, control 1. So I think we have achieved our objective. It is little bit coming outward, but you can adjust more. So control 7, I will go to the new motion study, select this motor and this crankshaft, rotary motion. Instead of 100 rpm, I will choose 50, click OK, and I will increase the time limit up to 20 seconds. Here see, control 7, go to this plain white, and now play the assembly. I hope that you have liked my video. I have tried very much to make this assembly as much